Hello. So right here I have a Proteus schematic demonstrating the automation of a ventilation control system in buildings. So the goal of designing this project was to make the control ventilation in building spaces, especially large spaces, more convenient by the users, but also to capture the concept of energy efficiency. I'll explain that later, how I've captured it in this project. In terms of components and how I implemented this project, as you can see, I've used the bare ATmega chip, which is common in the Arduino Uno and Arduino Nano, together with its reset switch and the clock circuit for the purposes of stabilization and timing. Also, I've used the PIR sensor, which is going to determine whether there are individuals or at least one individual in the living space, so as for the ATmega to determine the working of the actuating system. The ventilation system that I've tried to capture in this project are overhead fans, but also servo motors, which act as the driving mechanisms to either switch the opening and closing of the windows. The DHT11 temperature and humidity sensor is going to be the main sensor of the temperature. Actually, temperature is the only parameter I've been dealing with in this project. So it's going to be the sensor of the temperature, and it's going to feed it to the ATmega, which is going to determine the working mechanism of the actuating system. The LCD is going to display to us the conditions that have been sensed by the DHT, the working mechanisms, the status of the working mechanism, but also the status of the occupancy of the living space. Also here have the L293D motor driver. As you know, the pins here, they do not have much current. They are only about 40 milliamps, which cannot be used to run directly the DC motors. So the LCD, the L293D motor driver connected to a stable supply here is going to run these motors. So the temperature ranges that I've chosen for the actuating of these fans are not necessarily the standard ones set for human comfort. I've set four main ranges. That's below 24, below 30, and below 35. So these temperature ranges are going to determine the status of the actuating mechanisms. So that is below 24. The fans are not going to work, but also the servos will correspond to the closed position of the windows. But also above 25 but below 30, only one of the fans is going to be operating. But also above 30, we are going to see that both fans are going to operate. So those ranges, one can decide on the various after seeing the actual human comfort standards. I've set those only for this demonstration. So also the PIR sensor is going to be the main, its signal is going to be the main one that is going to be prioritized over the DHT11 signal, because and that's how I've captured the energy efficiency concept in this design. And sometimes you might have high temperatures inside, but there are no people inside. You can't continue running the mechanisms to ventilate the space while there are no people inside. So the PIR is going to be the component that captures that concept of energy efficiency in our project. So thank you.